Okay, everybody. Today our lecture will be I think so 1.4 and 1.1. Okay, our lecture today will be 1.3, which is complex numbers, and then when we finish, we will do 1.4. So the complex numbers. So that's mean all the real numbers. The real numbers does not include all numbers in algebra. Be careful. So the real numbers are the set of. So if you have a real numbers, suppose this one is real numbers. The real numbers, the notation is R. This one is all real numbers. Just to summarize, let's recap. This is the set of all real numbers. Inside the real numbers, there is some natural numbers. You can call it n. Okay, this is inside the natural numbers. So the natural numbers, this is the natural numbers. The natural numbers is a set of 1, 2, 3, 4, 5, 6 until infinity. Okay, that's the natural numbers. It's inside the real numbers. You have also the whole numbers. This is a whole number. So the whole number is just natural numbers, and you add 0. So the whole numbers is just the set of 0, 1, 2, 3, and so on. Okay, it's inside the all real numbers. You have also something called integers. So the integers is just the set of all whole numbers and the opposite. So you can think about -3, -2, -1, and you have 0, and you have 1, and you have 2, and you have 3, and blah, blah, blah. This is the called integers. Integers can be positive and negative. And remember, the natural numbers can be only positive, strictly. But the whole numbers can be positive. You see the difference between the terms? Again, the natural numbers is positive, strictly positive. The whole numbers is positive. Why? Because of the 0. You cannot say strict. Okay. And so on, and keep going. Also, you can have a Q. Q is a rational numbers. So the rational numbers, the Q is inside the natural numbers. The Q is the set of 8 divided by B, such that B is non-zero. It's like a fraction. If you have any fraction, irreducible fraction is called rational numbers. This is called rational numbers. This one here. This one is called rational numbers. Okay. Good. And now you have something called irrational numbers. So irrational numbers is inside the all real numbers. Irrational numbers is the set of, you can have square root of 2 is irrational numbers. Square root of 3 is irrational numbers. You can have also E is irrational numbers, which is Euler. You can have also pi. Pi also is irrational numbers. Okay, you got it. This is just to refresh your memory, so you will understand where we should go. You have to understand those before you start doing the complex numbers. So, okay, now remember one thing now. Not all real numbers. If x is a real numbers, x squared is equal to -1. You used to say is impossible, right? Is impossible in R, in all real numbers. Is impossible in R. Be careful, I say in R. R is all real numbers. It's not a real numbers. Why? Because if x is equal to 2, you have 2 squared is equal to -1, which is impossible. 4 is equal to -1, which is impossible. Okay? But it is possible on complex numbers. So the complex numbers is when you have x is to solve this one. So it's just x is equal to square root of -1, and I is equal to -1. I squared is equal to -1. That means I is equal to square root of -1. I squared is equal to -1. Both way is good. And I is called imaginary numbers. I is called imaginary numbers. So imaginary numbers, I is called imaginary. That's your point you have to understand. Okay? And then square root of imaginary numbers is just a -1. So now complex numbers. Definition. If 8 and B are for example real numbers, so then you can have the form 8 plus IB is called complex numbers. It's called complex number. And you can see with 8 and B, be careful, are real numbers, but I is imaginary numbers. And 8 is a real power, and B is an imaginary power. What I'm saying, 8 is a real power, and that B is called is an imaginary power. Okay, so let me recap. With 8 is a real number, but here in our case 8 is the real power, and B is the imaginary power. So you have to understand those. 8, if you have a 8 plus B, 8 plus IB, the 8 is a real power and the B is an imaginary power. You have to remember those. Okay, let's keep going to the next. So now the next we just have to, let me give you a couple example. So you can have a 3 plus I, for example, okay? And you can see here if you have 3 plus I, and you can see, let me summarize something first. You can have a 2 or 3 different things. Now, first, if 8, for example, if B is equal to 0, so you can have 8 plus BI will be then 8 plus, okay, for the I, remember for the I, you can write down the I here or here. It doesn't matter, okay? It's the same. Both are the same again. Don't feel confused don't feel confused about the position of the I. Both ways should be fine. Okay, let's keep going. So if B is equal to 0, so 8 plus BI is equal to 8. And then you can conclude here it's just a real numbers, which is a real number. Okay, this is you will have a real numbers if B is equal to 0. Now if B is different to 0 now, so you will have 8 plus BI is a non-real complex number. Okay, it's a non-real complex numbers. So now you have the last one, which is if 8 is equal to 0. So you will have for example, and also you have n. B is different to 0. So 8 plus bi is equal to bi. So this one is just pure imaginary numbers. Is called pure imaginary number. It's called pure imaginary numbers. And then remember, 8 plus bi is the standard form. Is the standard form. Okay, for example, let's define something about the meaning of a square root of a negative 8, for example. And 8 is a real number. 8 is a positive number. Definition. If 8 is strictly positive, then square root of negative 8 is equal to I, a square root of 8. Let me prove it. Prove mean, let's prove where this one comes from. Why is true? Prove. So square root of negative 8 is equal to the square root of I square 8. Why? Because if you go back here, I just use this one. Use this one. Replace negative 1 by I square. That's what I did here. Okay? And then this one is square root of I square and then square root of 8. And remember, square root of I squared is just I. And then square root of 8. That's it. Okay? Okay. Example. Let's do some couple example here. Let's do some couple example. Example, so 8. So you have a square root of negative 16, for example. So negative 16. So you will have I square root of 16. And you know 16, square root of 16 and 16 is a perfect square. So you can have just, it's equal to I times 4. And you can write down as 4i. Either way is good. But that way is the best one, the last one. Okay? Okay, let's do the next one. The b, if you have a square root of negative 13, for example. So it's just I square root of 13. Since 13, you cannot have a perfect square there. You just have to leave it like that because it's prime numbers. Okay, next. Let's try a square root of negative 48, for example. So 48 is I square root of 48. And you know 48 is just 16 times 3. And you know here I is equal to square root of 16 times square root of 3. And square root of 16 is just 4. And then it's I is 4i square root of 3. And that's it. Got it? Let me know if you have any question, please. Okay. So let's do the next one. D, for example, if you have a square root of negative 7 times square root of negative 7. Okay. One thing you have to remember about those kind of formula is this. Remember those formula, please. So square root of 8 times b is equal to the square root of 8 times square root of b. Got it? Now, if you have a square root of 8 plus b is always different. It's not true. It's always different to square root of 8. plus square root of b. And if you have a square root of 8 square, is always equal to absolute value of 8 is equal to the 8 if 8 is positive, is equal to negative 8 if 8 is negative. Okay? You have to remember those formula. So you have this one. And now the question is to find how to solve it. So you can do it different way. This one is equal to use this one. So you will have a square root of -7 times -7. And you know negative times negative is equal to positive. So then it's just a square root of 49. 7 times 7 is what? 49? It's just 49, I think so. 49. Okay, this one. Okay, let me change it here. You can write down like this. This one is just a square root of 7 times square root of 7. So this one is the square root of I squared times 7, and which is a square root of I squared and times square root of 7. And 7 times 7 is square. You can write down here square. And then you can end up having just 40. You can end up having here 49. Square root of 49. Okay. And then you can have here square root is just I. This one, square root of I square. And the square is inside the square root is just I. Okay. Oh, this one is everything. Okay, let me change here. This one. Okay, let me change it here. Let me write it down here. My bad. So you have square root, for example, of -7 times square root of -7. Okay, you have this one. So you have to now do it slow by slow. I was trying to do it directly. Let's do it slow by slow. You have I square root of 7 times I square root of 7. Okay. Now, I times I is I square. Got it? And then you have a square root of 7 times square root of 7. Good. And now you have I square root of 7, everything square. Let me write down some formula here. The square root of x, for example. And you have everything square is equal to the x. Square root of x, and the square is inside the square root is equal to absolute value of x. And then you can go down here to solve it. Up. Got it? What I'm saying up is here. Good. And now you reach here and you just apply that formula, this one. From here, you can apply directly that formula and you will see is equal to 7. So you will have here -1 times 7. And then you end up having -7. That's it. Okay? Now, let's do one more. So you can have, okay, let's do some rational numbers. So you can have a square root of -13, for example, divided by, let me change it to 12 maybe, to 12. Let me change it to 12. Square root of -12 divided by the square root of -4. Okay. This one is just I square root of 12 This one is I square root of 12 divided by I square root of 4. And you know, I square root of 12, I square root of 12, 12 is 4 times 3, divided by I, the square root of 4. And then here at the top, you have I square root of 4 times I square root of 3 divided by I square root of 4. And then this one will cancel out. So you end up having square root of 3. Good. Okay. And another example. So those examples will help you when you do your homework directly. So another example, you can write down the example for negative 8 plus square root of negative 128 divided by 4. And then write in standard form. And remember, the standard form is 8 plus IB. That's the standard form. Okay. Negative is equal to negative 8 plus I square root of 128 divided by 4. Keep going. Is equal to negative 8 plus I square root. 128, it's just a negative 60. It's just a 64. Just 64 times 2. Why I need 64? Because 8 times 8 is, because 64 is a perfect square. That's why. So divide by 4. And then now I will have negative 8 positive I. And here I have a square root of 64 times square root of 2 divided by 4. And here I have a negative 8 plus 8I square root of 2 divided by 4. Okay. And now it's easy. You can factorize by 4, the top and the bottom. So you can have 4 parentheses, negative 2 plus 2I square root of 2 divided by 4. And you can see here, cancel out the 4. And then you can have negative 2 plus 2I square root of 2. That's your final answer. Please repeat this one, okay? Train yourself. Okay. If you have a property, let's do some property, some couple property. So for complex numbers, 8 plus bi n c plus di. So if you have 8 plus bi, parenthesis, plus c plus di is equal to. So the first of all, you have to combine the real power and the imaginary power. You know, the imaginary power always have I. The real power is 8 plus c plus I, parenthesis, b plus d. That's it. Okay? Same if you have 8 plus bi minus c plus di. So you will end up having 8 minus c plus I, b minus d. That's it. Okay? For example, if you have found its sum and its difference, and write in standard form, So if you have to write down in standard form, so you have 3 minus 4i, and then you have plus negative 2, and then plus 6i, just for example. So here you have to combine first a real power. So the real power here is 3 minus 2, parenthesis, and you have I, negative 4, and then plus 6. And then keep going. 3 take away 2 is just 1. Plus 6 take away 4 is just 2i. That's it. That's it. Okay? Another example. So this one, let's call it A, and this one, let's call it B. If you have a negative 4 and plus 3i, for example, and you have a negative 6 minus 7i. So you subtract the 4, negative 4 minus 6 first, and then plus 3. You can write down the I first if you want. 3 plus 7. Here you have to be very careful. Very careful. Why I have here positive? Because negative times negative is positive. That's why I have here positive. Do you understand? You have negative in parentheses. If you put the negative sign inside, this sign will change. Will be the opposite. Then here have to be a positive sign. That's why I put the positive sign. Okay? And then you can have here, it will become negative 10. And then you have a plus 10i. That's it. That's all you need. Okay, now let's break it down about the multiplication form now. Multiplication of complex numbers. So if you have to multiply complex numbers, so let's do the same thing. So you have 8 plus b n, and you have c plus di. So if you have 8 plus bi, parentheses, times c plus di. Okay. This one is equal to 8c, 8 times c, and then minus bd. I will tell you where the minus come from. Plus 8d plus bc. You don't have to memorize it. Please don't. Let me show you. Proof. Proof mean let's prove if this one is true. So 8 plus bi, parentheses, and you have c plus di. So you have to distribute the multiply 8 by c and 8 by di. Okay, let's do this one first. So you will have 8 times c is 8c plus 8 times 8 di. Got it? Next, multiply the bi by c and bi by di is equal to plus bci, and then the next one will be b plus bd and I times I. Be careful here. You see this one? I times I, you have to remember I times I is equal to I squared is equal to negative 1. It's where the negative sign comes from. Okay, it's where the negative sign comes from. Got it? Okay, let's break it down. So you have 8c plus 8di plus bci, and then you have bdi squared. And remember, I squared is always negative 1. So you have 8c plus d plus ad I plus bci negative bc. No, bd. Got it? And now you can combine the real numbers and the imaginary numbers now. So you have 8c minus bd. That's the real power. That's the real power. And that's the imaginary power. Okay? So you have plus ad plus bc I. That's it. Okay? It's where it's come from. So you have always to distribute them if you face with multiplication power. Okay? Just let me give you one example. Example, if you have 8, for example, if you have 2 minus 3i times 3 plus 4i. So here you have to multiply this one by this one and multiply this one by here. And do the same thing. This one do the same thing by taking this one, multiply by this one, and this one multiply by this one. Okay? Okay. 2 times 3 is 6. 2 times 3. And then 2 times plus 2 times 4i. Okay? The next one is this one. You take a negative 3i times 3 and negative 3i times 4i. That's the way you do it. Okay. You see here? Here, you have to be very careful. You have to include the negative sign here, okay? It's the whole thing. It's the negative 3. Include the negative 3. You have negative 3i times 3. And then negative 3i times 4i. And that's it. And now you can have to distribute them. You have 6 here. And you have 8i here. This one is 8i. And this one is 6. Okay? Now, 3 times 3 is 9. So you will end up having just plus negative 9i. And then here you have negative 3 times 4 is 12. 12i squared. What did I tell you about the I squared is negative 1. Now, 6 plus 8i minus 9i, negative 12 parenthesis negative 1. And now negative times negative, it becomes positive. So you end up having 6 plus 8i minus 9i positive 12. And then now you can add them up and then subtract this one. So if you add them up, you have 6 plus 12 parenthesis and then plus 8 minus 9 parenthesis I. So what you have here is 18 minus I. That's it. Okay. That's it. Okay. I want to teach you something. If you have 8 plus b, everything square is equal to 8 square plus 2 8b plus b square. 8 minus b, everything square is 8 square minus 2 8b plus b square. If you have 8 plus b, parenthesis 8 minus b is equal to 8 square minus b square. This one you have to understand and know it. Example. If you have 1, let's see 2. 2 plus 3i. Everything square, for example. Okay, here you can do it in different way if you want. You can apply this one directly by using the first formula, this one. Yeah, apply this one directly. By applying, you can choose 8 here is 2, and the b here is 3i. That's it. Use it and replace it, and you will have it. Okay? You will have 2 square plus 2 times 8. 8 is 2 times b. b is 3i. and then b squared, which is 3i squared. That's it. And then now you have 4 plus 4 times 3i, and then you have 9 plus 9 plus times I squared. What did I tell you? I squared is negative 1. So you have 4 plus 12i minus 9. And then now you have to add them up. At the map, you have negative 5 plus 12 plus 12i. That's it. Okay? You can also do it that way. If you feel confused about this one, you can also break it down like 3i squared is equal to 2 times 3i times 2 plus 3i. Either way is good. And you can distribute them. Do the same thing I did last time. This one times this one, this one times this one, this one times this one, this one times this one. And you will see you have exact result. So you have here, the first one is 4 plus 6i, and then the next one is plus 6i, because here is 6, you have 6i, and the next one is 9i squared, and then you have 4, and then you have here plus 12i minus 9, and then you have 4 minus 9 plus 12i, and then this one is just negative 5 plus 12i. See, you have the same thing. Same thing. It's up to you. It's up to you. You can use either way. It's fine. Okay? Either way will work. Okay. Now let me go teach you about the complex conjugate. So the complex conjugate is when you change the sign from I. So if you have a let me do it as the property. Let 8 and b are real numbers. Okay. How I can define it? Okay, let's see. The complex conjugate. The complex conjugate of 8 plus IB is 8 minus IB. That's 8 minus IB is a complex conjugate of 8 plus IB. Got it? That's the way you have to think. Okay, now let me give you some couple example. The complex conjugate of 3 plus I, for example, is okay, let me write down here. The complex conjugate of 3 plus I is just 3 minus I. And the complex conjugate also of 3 minus I is just 3 plus I. That's it. That's all you have to know. Okay, example. If you have to, example 8, write in standard form. So if you have to write down in standard form of 3 plus 2I divided by 5 minus I. So first of all, you have to find the conjugate. Let's find the conjugate for the denominator. Okay, the one on the bottom, we have to find the conjugate. The conjugate of 5 minus I is just 5 plus I. And you have to multiply the 5 plus I, the top and the bottom. Okay? So this one is equal to times the conjugate of the denominator. Is 3 plus 2I times 5 plus I divided by 5 minus I times 5 plus I. And now it's good time to apply your formula I did right down the top. Is 8 plus b times 8 minus b is equal to 8 squared plus b squared. Use it. Okay? And then you can distribute this one. From here, you can distribute them. You have 15 plus 3i plus 10i minus 2 divided by, and the one on the bottom here is just this one. So you end up having 5 squared plus 1. Plus 1 squared, it's just 1. So here you have, add the map. So if you add the map, you have 13 and 13. So you have 15 minus 2 plus I, 3 plus 10. And divide by 26. And then now you have 13 plus 13i divided by 26. And which is 13 parentheses 1 plus I divided by 2 times 13. And the 13 we cancel out. And then you have here 1/2 plus I 1/2. That's it. Okay? Please try this one a lot. So because I have to give you a lot of homework and exercise on those, okay? Okay, now the next one we have to do is quadratic equation. The quadratic equation is, let me see how many minutes we have done. Okay, just let me stop here. So I will teach you about the quadratic equation next time. It may take too long, that's why. Okay, no worries, we will catch up.